All right, so we'll start now. Hi, I'm Siddhant. I am a third year computer science student, and we also have Japneet. He's a third year computer science student as well. And we will be talking about CNN and machine learning. So we'll just cover the background info of what is machine learning. So machine learning is a subset of AI that learns from data and make predictions on them. We also have a nice diagram that shows like the difference between AI, ML, and deep learning. AI is basically an idea where a program can sense, understand, and make predictions based on the data given. Machine learning is when you perform like algorithms and make predictive results. And deep learning is when you have a large amount of data and use many layers of neural network to compute a particular result. So the different types of machine learning, one is supervised machine learning, where it learns from the labeled data. As you can see in the table below, we already have classified data. And the common algorithms are linear regression, decision trees, neural networks. So Um, and yeah, that's a little bit about supervised machine learning. And we also have unsupervised machine learning where the data is not already classified for us and it's given in the data below. And the on the right side, you can see how if we label all the data points and if we check which one is the closest to the data point, we would label that as particular class. And yeah, that's normally how k-means clustering works. And dimensionality reduction is like if you reduce the dimensions, the you'd more likely you'd get the important features out of it. If you like increase the dimensions, you would have a lot of randomness. So lesser dimensions are better, but it's more likely that you will also lose out on important data. So it's important to have a good balance of that. And you also have reinforcement learning where the machine learns after giving a particular action. So you can see in the diagram that you have the environment that has a particular state and the agent gives an action. So based on the action, it either produces a new state or it produces a reward. So if that action gives a reward, it's more likely to do the same action again. So based on that, it learns on its own. And yeah, are there any questions? Okay. Are you covering it? Sorry. All right. So, yeah, this is basically a recap on what machine learning, supervised learning is, and why we need neural networks. So, the neural networks is when we have large set of data, and for example, images. It's very difficult to classify that data and give results. So that's why we have different layers, and yeah, that's a little bit about that.
Yeah, so I'll take it from here. And next, we are moving to what images are in the neural network and ML world. So, computer interprets images also as data. So, as you know, images are represented by pixels, and pixels can be grayscale or three channels, which is RGB, which is red, green, and blue. And each channel has if contains different numbers and data. So, coming on to the main point of our presentation today, what is a CNN? So, CNN basically means a convolutional neural network. It is a type of neural network and it's based on deep learning and typically used in computer vision. So, it has different types of layers compared to a normal neural network. And it's technically inspired by the visual cortex of the brain, like how our brain interprets images. We're just mimicking that for a computer, that how a computer can interpret an image using different type of layers. And predominantly it's used to extract features from grid like matrix dataset. And what CNN does in like a convolutional neural network is simplifies images to some math data points, and then we can interpret it to make different predictions. So let's take a deeper dive on it and see in the next few slides how different layers works and how do we get the prediction from that. So first of all, you have convolutional layer. So this layer is responsible to apply various filters on the images. The filters are also known as kernels here. And this is basically to extract key features from the images so that the computer can interpret the key specific features of an image. And the kernel slides over the input and computes a dot product, mathematical dot product between the kernel weight and corresponding image patches. And the dot product is calculated every time the kernel shifts, and the summation is mapped as a feature map. So we just interpret some specific features from the image and convert it to a mathematical feature map. Okay, the second is pooling layer. So what pooling layer is, it is responsible to reduce the sample size of a particular feature map. So as you can see on the right, we have two types of pooling layers here, max pooling and average pooling. So it's basically used to reduce the dimension. If you're reducing it 2 by 2 pool size, so we'll be taking the maximum of the four numbers in that grid and then make it like 100. So out of 29, 15, 0, and 100, we will be taking 100 there, and similar for the other three matrices, and it will be reduced to a 2 by 2 pool size. And what average is, it's pretty self-explanatory, so we'll be taking the average of that small 2 by 2 grid. And it increases the processing because it reduces the number of parameters the network need to process. And the output after the pooling layer is the pooled feature map, and the two types are max and average pooling, which we already covered. So after that, there's a fully connected layer, and this is the layer which is responsible for performing the actual classification. And so, like before the classification and the prediction, we have a flatten layer, which actually flattens the whole image into a single matrix, single data point. And we also have ReLU layer before that, which is rectified linear to have unlinear substances factored out on the flatter layer. So here's an image. You can see how it visually looks. So there's an input of a zebra, and then we are having a convocational and a ReLU layer. After that, we have like three layers, and then there's pooling, and at the end you can see a flattened layer, which is what we covered in the last slide. And after that, there's fully connected layer, which is responsible for making the predictions. And after that, we just have the output, which is dependent on all these layers.
So the idea of the ReLU function is that you would map the outputs as zeros and ones. So based on the activations and deactivations of neuron, it predicts the result. Um, and yeah, that's the whole point because we would have like different values for the pooling layer, and therefore the fully connected layer will help you just detect the pattern.
Yeah. So let's look at some popular CNN existing architectures. So there are different configurations of layers and that lead to different specialized architectures. So there's one LENet, which is one of the earliest CNNs from 1998. And it is specialized, like it specializes in handwritten digit detection. And it's made of two convocational layers, two pooling layers, and one fully connected layers. There's also VGGNet, which consists of 16 to 19 layers with small 3 by 3 filters. And it demonstrates the depth, which is like really crucial for CNNs. And then there's ResNet. These are all existing CNNs from previous times. And the ResNet it introduces the idea of skipping connections to allow the training of very, very deep networks. And it has like up to 152 layers before making the prediction. So let's look at some of the real world applications of CNN. Broadly classifying, there are three categories of applications. One is image classification, which we really use in our daily life. So it's like identifying objects, scenes, categories in different images, classifying what type of animal or plant does the image consist of. Then there's NLP, which is natural language processing, and it is used for text classification, sentimental analysis. For example, the spam detection in emails or sentimental analysis of product reviews. And then third, which is a really important application of CNN, is medical imaging, like diagnosis and analysis of medical scans, brain tumors, X-rays, pneumonia. So it's usually used for detect abnormalities in X-rays, MRIs, or CT scans. So we'll dive deeper into the real world applications of image classification, which is the main application of CNN. And there are four broader categories under that. First is healthcare, second is retail, autonomous vehicles, and social media and content moderation. So in healthcare, image classification using CNN really aids in diagnosing diseases by analyzing different medical images like X-rays, MRIs, and CT scans. And this application really enhances accuracy in early diagnosis and reduces the workload on the radiologist. So as you can see on the right, there are two images. The upper one is brain tumor detection. So it is totally based on CNN. So the brain tumor image will be like the X-ray image will be passed to a CNN, and using different layers, it will predict if there's a tumor or not, and what type of tumor even. So I'd like to show a working demo for that here. So this is a project which I made last semester, and it's pretty similar to that. I'll just show you guys that. Okay, so you can see it's right now hosted on a free domain. So this is a full stack project I made last year, and the core behind it is CNN. So this is just a basic front end and navbar and everything. So the main part which I want to show you guys is the brain tumor detection. There's the upload page, and then there's a drag and drop feature. We can like upload any image of brain tumor here. I really want to show you one. Let's download any image from Google, and I'll just like if I use any image from Google and upload it here. Yeah, and then if I do upload and predict, so it shows no tumor detected here. I guess this is because of the line. There's a specific format you need to put. Do you have that folder for the images? No. Okay. So yeah, you guys can explore this project later. It's hosted on euroscan.world, and using the specific instructions, you can upload images and then explore how this works. And the free code is also on GitHub if you want to explore how this works. So getting back to our workshop, a second application is autonomous vehicles. So image classification in autonomous vehicle also allows the identification of roads, obstacles, and pedestrians. So these days, like self-driving cars are really in demand and in the buzz right now. So like Tesla or other companies are moving to that. So that also works on predominantly on a CNN. So these systems rely on cameras and sensors to make real-time decisions, and it really ensures the safer navigation on the road. So the example use case, as you can see on the right, is obstacle detection. So it identifies the obstacle like pedestrian, other vehicles, and road signs. And the second is lane detection, which assists in keeping the vehicle within one lane on highways and streets. After that, we have social media and content moderation. This is something we really see on our day-to-day lives on Instagram, on Facebook. So image classification helps detect and filter inappropriate content on social media, ensuring a safer and more regulated environment. Like something you see like a sensitive content that's based on CNN. Example use cases here are content filtering, which automatically identifies and flags images containing explicit or sensitive content. And then there's facial recognition, which is used to identify and tag people in different photos. So yeah, then we have the demo, which my team member will go on with you, and then I'll catch back to you later. Right.
I mean, how are we gonna send this together? I'm gonna put it in chat. Yeah. Did you guys join the meeting? Yeah.
So like if you want to follow
Yeah.
along the Google Collab, because we're going to show you a demo right now, you can do that, or you can also work on that later if you want. It will be uploaded with the slides.
Okay. This is the link. All right. And yeah, we'll just wait for like 2 minutes. Sorry? The Zoom link. Where do you send it? Bro.
Zoom link should be on the event page.
Event page.
Yeah.
I send it into chat. Sure. Once both of y'all join, I'll send. Yeah. Both of us are third year. I'm sorry. How's that going? So do you have a background in like ML stuff or? Mm. Yes. These two.
You're doing this summer? Are you doing this summer? Okay, so wait. I'm not the way you get something. I don't know. I don't. Hang it.
What's the difference? Gee.
Oh yeah, but it seems in my box. Double in the I think about right here. You're right, Matthew. Yeah, that's the finger and landing it, I think. Okay. Oh, okay, this sounds weird, but that should be fine. But you know, yeah, yeah.
All right, did y'all join? Or okay, I'll send the link. So yeah, I mean, so we have three modules here. One is TensorFlow, Matplotlib, and now our goal is to just load the data set. Yeah, there we go. So first we need the training and testing set. So Um, sorry. Yo, Japni, can you hear me? Um, get this.
It's pretty you think so the hard for it right now. Let's use the artificial feature.
Yeah, sure. So this is how we load the data sets. And then we split into train and test models. Um, and now we have to ensure that the data points are correctly formatted. So that's why. Yeah, this is how we compute with the different layers. So here we have the convolution layer, and then there's a max pooling layer. Um, and then we do the same thing again over here. Take it. Yeah.
Okay, so basically what this demo is doing is we are using a CNN to identify different types of handwritten digits and classifying them using a CNN. So as you can see this image, so we are having different type of layers and then there's classification and activation functions. So in this code, this is what our actual model is. So we have like a sequential model, and inside that we have different layers. We have a convocational layer and then a max pooling, which we saw in the presentation before. After that, we have another convocation layer with 64 filters and activation layer of relo with that and max pooling. And then there's a dense layer of 1D vector, which is used to flatten the like the below, like flatten the things we are getting from back. And then there's a dense layer with 64 and 10 classes in the end. So after that, we're just going to compile the model here. So we are going to compile the model here. We are using an optimizer Adam, which is something little advanced. If you go deep into ML, you'll understand how the different type of optimizers work. And after running that, gee, one second, I guess I need to run this first. And yeah, and so here's what where we are going to actually train the model. So we are using the training images and we're using 10 epochs here to train the model. So what epochs does is that it reruns all the images for the training data set again and again. And we can do like a hit and trials and see like at what point our accuracy is something acceptable and the loss is really minimal. So for this demo, we'll just do 5 epochs to save our time. You can see like the accuracy is increasing, and the loss is reducing, and that's what's going to happen in all the layers. So it's already at 81%. It's rerunning all the images we have in the training data set of different digits. It's like handwritten digits of different layouts and everything. And once all the epochs run, then the model is trained to detect different type of the digits in the data set. Take. It usually takes long when you're going to train your model. This is somewhat a really, really basic model. Still, it will take some time. But when you're making projects on ML and using different model, just be prepared to have an hour or an hour and a half to train your model. And you need a good GPU. So why we prefer using Google Colab is because we're using cloud GPU right now. So it's not our own laptop GPU, and it's much faster than that. There are 1875 images in our training data set, and that's what's running in each epoch. So it's basically rerunning of all the data set, like all the training images, and then it detects the accuracy and the loss based on the training data set. So you can, so there's one data set, and then we segregate into training and then testing data. We don't show the model testing data before we are training the model. So that's for testing purposes, and we'll show that in the next cell. Now we are going to train the like test a model because we have an accuracy of 99.47%, the loss of only 0.16%, and the validation accuracy is 98%, and the loss is just less than 1%. So here we are going to measure the test loss and test accuracy based on this model we just trained. So after we run this, you can see that the accuracy on the test data set, which the model didn't see during all the epochs, is 98%. The loss is still really less. And we will just visualize the results now so that you guys have a broader idea on what's actually happening here. So this is just a basic matplotlib code where we are uh, using the test images, which are these images below. So these are all the images in the test data set, and the below lit digits in blue is the one which the model is predicting, and the one in the brackets is what the actual digit is. So as you can see, like it's pretty much predicting all the digits right except the one here. So this is a three, but the model predicted five, and the actual digit here is three. So, but the prediction accuracy is really high for this, and that's how we actually train a CNN model. So if we visualize the accuracy and loss on two different graphs, so that's how it will look. So you can see the training accuracy as well as the validation accuracy is pretty high, and the loss function goes like the loss is really high initially, and then when we run multiple epochs and during training a model, it goes down significantly, and then we have like minimal loss. So that's like a basic demo. It's not something really complex. It's just classifying digits, handwritten digits using a CNN. But this has wider applications than you can use to make your own project using CNNs or different type of ML models. So that was our presentation and demo today. And thanks a lot. Thank you. Yeah, sure. Uh,
There was a CNN that post. You could check out which one. The images, the zebras and horses.
let's you want me to show that.
Yeah, that's what.
Like,
Or
do you know the Dave pneumonia thing? The if you want to show license.
yeah, type Iris.
Let me connect mine so that I
Yeah.
can this is the one which I was showing before, but I was on a different laptop, so I didn't have access to write images. So I'll just show you this. So what this is a model which I actually trained myself. So what this does is it classifies different types of tumors based on a CNN in the backend. So what I did, like I had like more than 50 epochs here. And then the first training was detecting if there is tumor or not. And then there was a further classification. It's what type of tumors. So there are three types of tumor this model detects. So I'll just show you. So like these are different folders which the model haven't seen of. This is no tumor images. It's pituitary tumor, glioma tumor, and something I can't spell right now. I'm not a medical kid. So if I just put this image and then I submit anonymously. Oh, wait. And if I upload it and to the model prediction, it says tumor detected. But if you want a specific type, you can even do that. Sorry. Yeah, because it's loaded on a GCP paid version, so that's why. Not sure what this is doing. Yeah, so this is an image where there's no tumor and choose a different image. Seems like there's something. Yeah, so this is the telling what type of tumor it detected and what's the probability of that. So this is based on a binary classifier, which is a different concept. So like zero if there's no tumor, one if there is, and then we have a multiple classifier which is zero, one, two, three for different type of tumors. So that's how this is working. And yeah, so this is just a basic project. It's nothing really big, but CNN is used in like different applications. You can see like medical imaging, and then the self-driving cars using CNN in their back architecture. Yeah, if you want to show something there, free to show my
Um,
tablets.
I mean, currently we haven't built our project yet, but our project is like we're doing a physiotherapy app where it detects emotion of patients and basically predicts the type of exercise they're doing. And based on how they move, they'll also give like suggestions on the posture. So that's something we're doing it by the end of the year for our MacAI project. So yeah, that's our application that we're doing. Yeah. Yeah.
Once you have pretty much done, any questions? Yeah, sure.
Well,
I'll just give me the cable for that.
yeah, thank you guys for coming. And